All right, so simplifying radical expressions, examples, this is a level 1. So this one, I'm going to show you an example. If you feel like you can do it, pause it, try it out, and then check to see if you got the right answer. All right, so I'm going to start with this. If I have the square root of 32, first thing I ask myself is, what are the factors? How can I break this up where I can find one of my perfect squares? So I have a list of my perfect squares. These you should have memorized. 4, 9, 16, 25, 36, all the way up to 225. And for the most part, you're probably going to just use these top ones, are usually the case. So I think to myself, 32. What goes into 32 that happens to be one of my perfect squares? And I think to myself, well, I know that 32 can be broken up to the square root of, let's say, 16 times the square root of 2, because 16 times 2 gives me 32. So therefore, here I see this is a perfect square. So this one actually simplifies to 4 and radical 2. This one simplified to 4. This one stayed radical 2. And that's all you can do there. So this is the simplified version of that radical symbol. Okay, let's take a look at another example. Okay, all right, so this next one, I introduced a variable here. So let's see how we can break this up. Well, 75, that comes kind of easy to me. I think of money. I say, well, 75, which one of my perfect squares? 25 is one of the factors, the largest factor. So I can say that this is really the square root of 25 times 3, right? And what about the x portion? Well, x is all by itself over there. Now, of these 3 factors here, this is the only one here that is a perfect square. And so I can simplify this part, turns into 5. And these two, well, unfortunately, they're not perfect squares, so they have to stay within the radicand. And that would be just like that. And that's my simplified version. Okay, let's try one other. Again, feel free to pause the video and try it out yourself before to see if you get the right answer. All right, so here, a little bit more difficult in the sense that it's got more letters and stuff, but no big deal. 9, well, that already is one of my perfect squares, so I'm going to say square root of 9. Times. Now x cubed, I want a perfect square, so really I can say that this is x squared times x, right? If you remember your properties of exponents, these get added together, gives you 3, so I can split that up just like that. And so here I see a perfect square, I see another perfect square, and now one you have to leave alone. So square root of 9 is 3, the square root of x squared is x, and then this x, is extra x, has to stay within the radical symbol. And there you go. There's that answer right there. Okay, last but not least, here are 2 guided practice problems. Try that by yourself. Pause the video for sure. Try them out, and then come back and see if you get the answer. All right, if you're back, I just want to do this quickly because we're hitting the 3-minute mark here. So let's see. 24. Well, I can see this as 4 times 6. 4 is my perfect square, so I get 2 radical 6. Done. Over here, I wonder, well, 25 is a perfect square, and so is x squared. Both of them happen to be perfect squares, so my answer, 5x. Done.